Hello and welcome to chapter number 7, Law of Returns. Let's understand first the concept of production. The act of making goods and services. In short, adding utility to any object is called as production. Adding utility to any object is called as production. What do you mean by production function? Production function shows that how much maximum quantity of a commodity can be produced. How much maximum quantity of a commodity can be produced per unit of time. Production function explains how much maximum quantity can be produced. How much maximum quantity of a commodity can be produced per unit of time. Per unit of time can be produced per unit of time with the given amount of input. 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 When the best production technique is available. When the best production technique is available. So, production function explains how much maximum quantity of a commodity can be produced. How much maximum quantity of a commodity can be produced per unit of a time. In a given period of time, how much maximum quantity of a commodity we can produce with the given available inputs by using the best available technology. So when we are using the best technology on our available inputs in a given period of time, how much maximum quantity of output can be produced. In short, it also tries to explain how much minimum amount of input are required to produce a certain level of output with the best available technique of production in a given period of time. So this is called as production function. How will you explain production function with equation Qx? Qx represent output of a commodity. F refers to function and F1, F. So here we can write Fy, Fz, etc. Okay. So F and Fy, Fz, all this represent here inputs and Qx represent output. F represent function. Output is dependent on input. So inputs are dependent variables. Output is independent variable. Output is dependent variable. Inputs are independent variables. Output depend on input. That is why output is called as dependent variable. In this case, F1 is Fz, Fn, all this represent the input needed to produce the total output. Let us simplify our studies and we take only two inputs right now. L, which represent labor, and K, which represent capital. Now, let us understand this equation with respect to short run and long run. Now short run refers to the time period during which amount of one or more input can be changed, but other input will remain fixed. Will remain fixed, they cannot be changed. That is called as short run. For example, let's say you are running a plant, you are running a factory, okay, in which there are fixed machinery. Now if in case you want to increase the output, you want to increase the output in a very short period of time. You cannot install new machineries. You cannot get new tools, new machines. What you can do is, you can just make your laborers maybe work for extra hours. So in this case, your plant, your machines, they will remain fixed because the time period given to you is very short. You cannot expand this. You cannot increase plant. You cannot increase machinery. But what you can increase? You can increase the number of hours your laborers are working. So the only way to increase your output in such a short period is by making your laborers work for more hours. And that is how you can increase your output. That is called as short run. But then we have long run. What do you mean by long run? Long run refers to that time period which is long enough to change all your inputs. You can increase your plant capacity, you can install new plant, you can get new machinery, you can get new laborers, you can increase your raw material. Everything can be increased. Nothing is fixed. Everything can be increased, everything is variable. And that time period is called as long run. Now, we have two types of production function. Short run production function and long run production function. What do you mean by short run production function? So a short run production function refers to a situation when only one input is variable. And all other inputs we are assuming to be constant. Now for example, in our example we will say that labor is variable. To increase the production, we can increase the number of laborers. But K represents capital. Our capital is fixed. Short run production function refers to a situation when only one input is variable and all other inputs are assumed to be fixed or unchanged. Now, capital here is representing the set of machines which we will not increase. The only thing we can increase here is labor. This is also called as law of return. So in this case, it is called a short run production function, and short run production function will be expressed as QX FL function with respect to labor, because the only thing we can increase here is labor. So when I have to express short run production function, I will express it in this format, in this equation. Okay, it is also called as returns to a factor. It is also called as law of returns. Now, the second type of production function is long run production function. It is that situation when changes in output can be brought by changing all the inputs. Everything can be changed, nothing is fixed. So for long run production function, we will use this equation, because you are able to increase your set of machines, you are able to increase your number of laborers, everything. So in long run production function, nothing is fixed, everything is variable. But in short run production function, only labor is variable, everything else is fixed. Now, before we go ahead in the chapter, let us also talk about 3 more things in the chapter. First, what is total products? Total product. So total product refers to total physical product, total amount of commodity produced during the specific period of time by combining all the quantity of variable factor with a given quantity of fixed factor. By combining all the variable factor with the fixed factor, when you combine all the variable factor and fixed factor, how much total quantity of the output you can produce? That is called as total product, which is also called as TP. I repeat again, total output that can be produced by combining all the variable factor with all the fixed factor. It is called as TP. For example, 10 labor, 1 labor produces 20 boxes. So 100 labor produces, 101 labor produces 20 boxes. So 100 labor produces how many? 100 into 20, which is equal to 2000 boxes. So total product is 2000 boxes. Second is average. Second is average product. Average product refers to average physical quantity of a commodity. Okay, it refers to average produced. It refers to a output per unit of a variable factor with a given quantity. In short, average product. So, formula for average product will be AP. Okay, it represents average product of labor. Average product of a labor refers to total product of labor divided by number of labors. For example, 100 labors produced 2000 boxes. So 1 labor produced how much? 2000 divided by 100. 20 boxes. So this is called as average. The third is marginal. Marginal product refers to change in total product resulting from the use of one additional unit of a variable factor. In our example, variable factor is labor with a given quantity of fixed factor. In short, every additional variable factor is producing how much additional output for you. That is called as marginal product. The formula for the same will be marginal product of labor is equal to change in total product upon change in labor. Upon change in labor. Let's say 100 labors were producing 2000 boxes. 101 labor are producing 2020 boxes. So additional 1 labor has produced extra 20 boxes. Extra 20 boxes. How much are the additional boxes? How much? 20. Additional labor is how much? 1. So additional 1 labor has produced 20 boxes. So that is called as marginal. That is called as marginal. Total product, average product, marginal product. Now we are going to talk about behavior of total product, average product and marginal product when you keep on increasing your variable input on your fixed input. In our example, we are taking our fixed input as machines and variable input in our example is labor. So let us understand, when we keep on increasing the labors, which is our variable input, on our fixed input, how our total product, average product and marginal product will get affected. And that will help us to understand the law of variable proportion. So here, first let us say number of laborers or number of workers. Then we have total product. Then we have average product. Then we have marginal product. Okay. Now, so now we are assuming here that we have fixed machinery. Okay, we have fixed machinery. Now on our fixed machinery, when we keep on increasing our labors, what will be its impact on TP, AP and MP? Okay. Now let us take an example that there is a workshop which has got 5 machines to produce a ballpoint pen. Okay, ballpoint pen, which can produce, there are 5 machines. All of them are making different things. One machine is making a body of the pen, other is making the cap, third is making the clip, fourth is making the refill, and fifth is refilling the ink in the refill. So there are 5 such machines which are doing production of ballpoint pen. Okay. Now on this, if we start increasing the number of labors, how will our TP, AP and MP get affected? Because in our example, the only thing we can increase is labor, because we are going to talk about short run production function. So our capital is going to remain fixed. So now if you start increasing, when there is 0, of course it will remain 0. Now when there was one labor was working for all the 5 machines, so he was able to produce only 100 pieces. But now when we got one more labor, so now the number of labors we have are 2. So together both of them are able to produce 220 machines, 220 ball pens. Now we employ one more labor, 3. So that will bring our total product to 360. 3 of them together are producing 360 ball pens. Then 4 of them, we employ one more labor, are producing 520 ball pens. We employed one more labor, 5 of them are producing 650 ball pen. Now all the 5 machines are fully occupied. But still we think, let us get more labor, maybe they will get some extra help, the existing laborers will get some extra help, or maybe on one machine if two people will work, they will be able to work faster or efficiently. So we keep on increasing the number of laborers, 2, 6, 7, 8, 9, 10, 11. So because of which our TP, total product, becomes 750, then it becomes 840, 880. So as you kept on employing the labor, your TP kept on increasing, but we will talk about it, that how is it increasing. Now after 8th labor, the TP became stagnant, it is not increasing anymore. In fact, after 9th labor, if you continue employing more laborers, your TP falls down to 830 labor, and then finally it falls down to 770 labor. Now with the help of this, we will be able to get our average. Average formula is always TP upon workers. So in this case, 100 divided by 1, 100. 220 divided by 2, 110. 360 divided by 3. 120. Just 1 minute. Okay. Then 520 divided by, I have to change the pen. Okay, 110, 120. Okay. Then, so as you keep on 520 divide by 1, 2, 3, 4. Okay, 520 divided by 4. Still you get 130. Okay. 650 divided by 5. 130. Okay, so we can take out the average like this. 125, 120, then 110, 97.7, 83 and 77. Let us also see how every additional labor is adding to the output. So when there was no labors and then I added one labor, my total output increased by 100. But when I got one more, 100 की जगह पे 220, that means मेरे additional labor ने 120 pieces extra बनाए. The additional labor made 120 pieces extra. Third labor के आने से 140 pieces extra बनने लगे. 360 minus 220. Now 520 minus 360. 520 minus 360. So now the number of extra pieces produced are 160. 650 minus 520. So this will give you what? 130. 750 minus 650. That will give you 100. 840 minus 750. 90. 880 minus 840. 40. 880 minus 80. 0. Minus 50. And here I will get minus 60. So now in this case, if you see, let us understand. If you see till unit 5, okay, now let me understand the relation and the behavior of TP, AP and NP in our this example. Okay. So, in this case, if you see, up till labor 5, from if you see till unit 5, in this case TP is increasing 100, 120, correct? TP is increasing and it is increasing at the increasing rate, at a increasing rate, correct? 100, 120, 365, but till which unit? Till unit 4. If you see till unit 4, it is increasing at an increasing rate. After unit 5, also it is increasing up till unit 8. Unit 8 tak. It is increasing, but it is increasing at a diminishing rate. At a diminishing rate. In fact, at unit 9, it has reached its maximum capacity. And then after unit 9, labor number 9, if you employ more labor, your TP start falling. It is decreasing. Your TP start decreasing. So your TP here is showing 4 type of behavior initially as you keep on employing the labor. So my plant capacity was 5 labors because there were 5 machines. So till 5, my TP was increasing at an increasing rate. But 5th ke baad, my TP started increasing because on the labor 5th, all my machines got fully occupied. Before that, I was underutilizing my capital. My lot of machines were not utilized completely to their capacity. As a result, after that, when they were working to their fullest capacity, I did not increase now machines. I'm just increasing the number of laborers working on them. So after that, my TP started increasing, but it started increasing at a diminishing rate because the efficiency of my machines became less. Why efficiency became little less? Because the efficiencies became less because already there was a fixed proportion in which they were working and that proportion got disturbed. In fact, till one point TP kept on increasing, but after that they were totally, the maximum number of labors you could employ has been, that maximum limit has been achieved. Because of which after that when you kept on employing more labor, what happened? Your TP started falling. So your TP initially is increasing at an increasing rate. Then it is increasing at a decreasing rate. Then it is reaching to its maximum capacity and then it is falling. What is happening to AP? AP is AP 100, 110, 120, 130. Initially AP is increasing. Then AP reaches its maximum capacity. At that time AP become constant 130, 130. Then AP starts falling 125, 120 and it keeps on falling. But yes, overall it remains positive. What about MP? MP is also 100, 120, 140, 160. MP is also falling. When AP has reached maximum of 130, from there, at that time if you see AP and MP are equal. When AP is maximum, at that time it is equal to MP. It is equal to MP. They both are equal. Okay, when AP is maximum and then MP start falling. MP becomes 0 also and MP becomes negative also. Initially MP is falling, then MP becomes equal to AP. When AP is maximum, then MP start falling, MP becomes 0, MP becomes negative. Okay, so these are the behaviors we have seen of individually TP, AP and MP. Now, let us understand this relation with each other. So if you remember, I told you TP was showing 4 behavior. What 4 behavior? Initially your total product was increasing at an increasing rate till labor number 4. When TP was increasing at an increasing rate, MP was 100, 120. At that time, MP was also increasing. MP was also increasing. This is the first comparison we can see. Then when TP was increasing at a diminishing rate till unit labor number 8, at that time MP was falling 130, 190, 40. When TP was maximum, MP was 0. MP was 0. When TP started falling, MP became negative. MP became negative. These are the 4 relationship of TP and MP. As long as your total product is increasing at an increasing rate, that means every additional labor is producing more and more output for you. That is why your MP is increasing. Now when TP is increasing at a diminishing rate, that means your additional labor is producing output but not more. Is producing output which is lesser as compared to what he was producing earlier. That is why your MP is falling. Now when your TP has reached maximum capacity, that means your additional labor cannot produce anything more than this. That is why your MP becomes 0. And when your TP starts falling, that means additional labor is not doing any work for you. In fact, that additional labor is because of that labor you are losing out on your products. So that is why your MP starts falling. So TP increasing at an increasing rate, MP also increasing. TP increasing at a diminishing rate, MP is decreasing. TP reaches maximum, MP is 0. TP starts falling, MP becomes negative. These are the 4 relationship of TP and MP. Let us understand the relationship of AP and MP. If you see, initially, I'm so sorry, both were increasing. Do you know why both were increasing? Let's see AP, MP, 100, 100, 110, 120, 120, 140, 130, 160. They both were increasing because MP was more. Why were they both increasing? Because MP was more. So as long as marginal product was more, they both were increasing. AP and MP both were increasing. Now when AP became maximum and constant, it was equal, right? See here what we were noticing, MP was more. Here what are we noticing? That AP and MP are equal. Now when they both start falling, at that time AP is more. So when AP is more, they both start falling. Can you see 125 both are falling, but AP is more. And also throughout AP remains positive. MP becomes positive also, 0 also and negative also. So there are three relationship of AP and MP. As long as MP was more, both were increasing. When AP was maximum and constant, it was equal to MP. When AP started becoming more, both started falling. Both started falling. And throughout AP remained positive. MP remained positive, became 0 and became negative also. So these are the relationship of AP and MP. So this entire table and this relationship has explained us one law, and that law is called as law of returns to a variable factor, which says that as more and more unit of variable factor are applied to a given quantity of a fixed factor, total product may increase at an increasing rate initially, but eventually it will increase at a diminishing rate. It will increase at a diminishing rate, assuming everything else is constant. What all things are assumed to be constant? Technology is assumed to be constant. Some inputs are kept fixed, only few are increased. In our example, we are increasing only labors. It is also assumed that technology is such that it is possible to change the factor proportion. It is also assumed that all the units are homogeneous and are equally efficient. Now, this is law of variable proportion. It is called as law of variable proportion. In this, we have seen three stages. Which three stages we have seen? So here, let me erase this. One stage, one and one. So in this case, if you see, this is stage 1, this is stage 2, this is stage 3. Stage 1 is a stage of increasing returns. Stage 2 is a stage of diminishing returns. Stage 3 is a stage of negative returns. Is a stage of negative returns. These are the three stages we have. Stage 1, stage 2 and stage 3. Now, why is stage 1 called as stage of an increasing return? If you see in this, as you keep on adding variable input to your fixed factor, your MP is increasing, your AP is increasing, your TP is also increasing. So this is a situation when maximum returns you are getting by employing your variable inputs on a fixed input. Stage 2 is called as diminishing or constant returns. Okay, stage 2 is diminishing return, because in this your TP is increasing but at a decreasing rate, at a diminishing rate. Your AP and MP both are falling, and in fact your TP reaches maximum in this stage. Stage 3, TP is decreasing, MP is also falling, MP has become negative and AP is falling. Let's understand this diagrammatically. The diagram of this chapter is very, very important. Okay. I'll have to erase this. Let me write down the relationship again so that you understand this bit better. TP, MP. What was the relationship? Initially TP was increasing at increasing rate. At that time MP was increasing. Then TP was increasing at diminishing rate. At that time MP was falling. When TP was maximum, MP was 0. When TP started falling, MP became negative. This is the relationship of TP and MP. Alright? Okay. Let's write down the relationship of MP and AP also. AP and MP. Initially both were increasing. MP was more. Okay, when AP was maximum, it was equal to MP. They both are falling. At that time AP is more. AP remains throughout positive. MP becomes 0 also and it becomes negative also. Okay, I have just written down in simple language to understand. We are going to draw two diagrams in this. This is going to be for total product. And here we are going to show the number of labors. Okay, so first we are going to show total product. Initially your total product was increasing at an increasing rate. Initially it is increasing at an increasing rate. Then increasing at a diminishing rate. Then becoming maximum and then start falling. So in this case, if your diagram, if your curve, if it would have increased at the same rate, it would have gone straight up like this. Correct? Increasing at an increasing, that is a little bit concave like this. Now, in this case, now kids, if you see here this point is called as point of inflection. Why it is called as point of inflection? At this point, if you see, the curve of TP is changing. The curve of TP is changing. Okay. Why it is changing? Because from this curve, your TP will start increasing at a diminishing rate. Yeah. This is called as point of inflection. Now, can you see at this point, let's call this point as P. This is a maximum point where TP has reached. Let's call this point as A. We call this point as M. Okay. Now, let's draw, this is entirely TP where we have shown TP is increasing at an increasing rate, then diminishing rate, reaching maximum, falling. ये हो गया हमारा TP का. See, increasing at an increasing rate, increasing at a decreasing rate, reaching maximum and then falling. Now, on this curve, we are going to show both AP and MP 0, and here we are going to show labors. Now, you have to make sure that the points here should match each other. So, first your MP, so you have to make sure that at the point of inflection, your MP will be maximum. And at the point of maximum here, your MP should be here. So when TP is maximum, MP should be 0. At the point of inflection, MP should be maximum. Okay? Okay. Now we are going to draw AP. When at this point, we have to make sure that we draw AP as maximum. You have to try the proper ruler. Sorry, it's just a bit. Yeah. So now kids, look here. See, when AP and MP are intersecting each other. Okay. And though these are done dotted, but this will do line. So now, in this case, if you see, here, let's call this as L1 and this we call as L2. L1 and L2. Now, did you see when this is AP? See now, if you see, and this is point M, this also I'll call as point M. When AP and MP are meeting each other, that is called as end of stage 1. When TP is maximum, it is called as MP is 0. So if you see in this case, when AP and MP are equal to each other, that is the end of stage 1. When TP is maximum, MP is 0, that is end of stage 2. And after that, we have stage 3. Then we have stage 3. When AP and MP. So this dotted line is just to show point of inflection and MP being maximum. The dotted line is only for that. But the first solid line black which I have drawn, that I have drawn to show end of stage 1. And stage 1 ends when AP and MP are equal to each other. Stage 2 ends when TP is maximum, MP is 0. MP is 0. That is an end of stage 2. And uske baad there is stage 3. Now what could be the reason? Also, one more thing. Did you see in the beginning MP was more, both were increasing. See, both are increasing and MP was more. So MP curve is above. Then they both were equal. At this point they both are equal. Then AP is more and they both are falling. Both are falling and AP is more. And MP becomes negative, AP remains positive. So all the four relationships we have shown on the diagram also. Now what could be the reason for increasing returns or diminishing returns or negative returns? So increasing returns were in the beginning because there was fuller utilization of the fixed capital happening. Correct? Till unit 5, till machine number 5, you were underutilizing. So as you started using it to the fullest capacity, your returns were maximum. Also in the beginning, because you were working, as you were employing more and more labors, the efficiency of the labors were increasing. Maybe they were practicing division of labor also. So very nicely all were carrying out their work. As a result, the efficiency was highest. So our returns were increasing. But then stage 2 में what happened? There was an optimum proportion, like one machine, one labor. हमने वो disturb कर दिया, एक machine पे 2 labor ला दिए. जो proportion में machine and labors were working, we disturb that proportion. इसलिए TP started increasing but at diminishing rate. Or maybe we did not get the perfect substitute. Maybe we decided more labor can be employed in place of capital. That is what we thought. So we decided to substitute capital with labor. Maybe that was not the proper decision to be taken. Third, negative returns because there was overcrowding of labors that led to management issues. Too many laborers were working on the same machine which are not needed. All the machines were the number of laborers needed on each machine was more than the number of laborers were more. As a result, the productivity started falling. As a result, the output started decreasing. Also, management problems, managing too many laborers can be a management problem. So, these were the reasons for increasing return, diminishing return and negative returns. Now, a rational producer should operate in which stage? Stage 1, stage 2 or stage 3. So, one thing is clear, there is no way that he will operate in stage 3. Because MP is negative, TP is falling. Therefore, he should not operate in stage 3. Stage 1, he is trying to increase his TP by employing more and more labor. Correct? But in stage 2 also, he is able to increase his output by employing more labor. Though the rate at which the TP is increasing is less, but still TP is increasing. So it is very common, it is very simple that he should operate as long as he should keep on employing more and more labor as long as TP is increasing at increasing rate or diminishing rate. But if by employing more variable input, if his total product is increasing, he should keep on doing that. But he will stop doing that when employing more variable input will give him negative returns. So ideally he should operate in stage 2. Stage 3 is called as absurd stage. Is called as absurd stage, in that he should not operate at all. Stage 2 mein your additional labor is contributing some extra output for you. So it is okay, though it is at a lesser rate, but it is okay to operate in that. So that is why, so that all the fixed factors are utilized completely. So stage 2 is an ideal stage for the producers to operate. And kids, please make sure to have this diagram where you show point of inflection properly, which is a point where the curve changes. Okay, this should meet the maximum point of MP. This should be at the intersection and TP maximum should be here. Is that clear? Alright kids, so that was a very easy chapter, chapter number 7. Thank you so much.